Hi everyone. Welcome to this new session from GDG MISO and Women Techmakers MISO. And we conduct events like this so that people could learn more about open source technologies and Google technologies. We basically invite speakers to speak on various topics. And today it's going to be about Android 11. So Miss Usha Rangaraju is the chapter lead, and she has played a big role in making these events happen. If any one of you are interested in conducting a session like this, about technology that you have had experience with and you want to share awareness about it, then you can contact her through Twitter. The links are also put up in the description. And this is the core team of GDG MISO, and it's not just GDG MISO. So basically, the core team, it's because of the combined efforts of these guys that we have managed to conduct events every week from three different organizations. There is GDG MISO as well as TensorFlow User Group MISO and Women in Machine Learning and Data Science MISO. And we have more such events lined up. And as I told you before, we have events every week from these three organizations. And if you want to stay tuned with these events, you could check up these links. I've also put them down in the description. So without further delay, we are going to start with today's session. And we have two speakers here with us today. And we are going to start with Saurabh Arora, who is a Google developer expert, and he's going to be talking about uh, adaptive apps for the privacy changes that are in Android 11. So would you start?
Hi, everyone. Thank you for tuning in on a Sunday afternoon, Sunday morning, let's say. Yeah, Sunday morning. And I'm Saurabh Arora. I'm a Google developer expert for Android, and I work at Viki, which is a video streaming company based out of Singapore. All right. And today I'll run through some of the privacy changes that were introduced in Android 11 and what developers would need to do to prepare for these changes that are upcoming in the new Android 11, which has already reached beta. So, what privacy changes really would mean is let's dive back a bit into the last couple of releases for Android. So, the last couple of releases, there's been quite a lot of focus on privacy. And these changes are basically very important to protect the user's data and let them know what is happening with their data on their smartphones. You know how smartphones contain a lot of information about our lives. And it's really important that as a user, I trust the device that I'm possessing. Like I really trust the smartphone that I have, and I trust that it's taking care of my data and it's not abusing anything that's on it. So with this mantra in mind, accordingly with each release, there's been a coordinated effort to make Android a more privacy-centered platform. And Android 10 actually paved the way for Android to evolve into a platform where there's a lot more emphasis and focus on protecting users' data. So with that in mind, let's look at what changes does Android 11 bring to the fold. So the changes we look into can actually be bucketed into various sections such as permission changes, foreground service type, scope storage, package visibility, and data access auditing. Right? So these are the changes. We'll look into them one by one. So first up, let's look at permission changes. Like this in this section, we'll cover all changes which are related to granting and denying permissions to your app to access users' private data. So in in Android 10, when users were presented with an option to give the location only permission, users selected it more than half of the time. So Android 10 had that dialog where you could do allow permission all the time or only when using the app. So these were the options that were presented to the user. So when this option was presented to the users chose to give permission only when in use, more than half of the time. And then based on this feedback that users only wanted to grant access to location only when the app was in the foreground, that is when it was being used, Android 11 decides to extend this changes to microphone as well as camera permissions. So along with using the app, you will now have users will now have an option to grant temporary one-time permission for location requests. So as you can see in the dialog here, there's an option which says only this time. So what users could do is they could say, hey, I just want this app to use location only this one time, not just in foreground, only this one specific time. So next time the app comes into the foreground again, you'll have to ask for this permission all over again. And similarly, the same concept is now being extended to microphone access. So imagine this is like a transport app, and that provides you VoIP services. So in order for the, let's say, the rider to connect to the driver, and user wants to make a voice call at this point. So the user has an option to say, hey, I just want to use this one moment. I don't want you to be able to permanently record my audio. So the user can say, okay, only grant this permission this one time. Similarly for camera access, in case your VoIP app also supports video calls. So the user could say, just do this one time. So what changes are actually needed for you from the users? Actually, nothing, right? Because if your apps are currently following the best practices for asking permission from the user, then your app were already living with the reality that the user could go to the system settings and revoke that permission for you. So permissions could never have been taken for granted. The best practice dictated that you should not cache these settings as well, because they could get in sync with the system, given the fact that user could go to the system settings and deny them. So if you were following these best practices, essentially nothing changes for you, because you get the permission grant for this one time. Then when the user opens the app again, best practices dictate that you always check for permission. If the permission isn't there, you request for it. And if that protocol is being followed, there's actually no changes needed on the engineering side or the developer side of things. But given that I just spoke about best practices, let's just take this brief moment to actually go through some of the what these best practices in terms of permissions really are. So anytime the user performs an action that needs a permission, us developers, we need to make sure that the permission has been granted. And as I mentioned earlier a while back, permissions should never be cached as they can get out of sync. So developers should always check for them before performing any action. And if the permission is not granted, we go ahead and request for it. But what if the user denies the permission? Well, if the user denies the permission, make sure to fall back gracefully and explain to the user that the current functionality that your app is offering won't really work because the user has decided not to grant this permission to them. All right. And one more thing is, do note that this one-time permission option will appear for all apps running on Android 11, irrespective of your target SDK. So even if you do not update the target SDK in your manifest or your build.gradle file and don't specify that you are yet ready to target 11, this change will still be impacting your app. So as long as the user has an Android 11 device and he or she runs your app on the device, these new one-time permission option will still be visible to the user. So I hope people are already following the best practices for permissions. They do not assume that the permission is granted to them. And if that is the case, which I really hope is the case, then this should just be a seamless change and your app should just continue to work out of the box without any changes needed. Okay, so that was about one-time permission. Now let's look at how Android 11 makes location permission even more special. So to give users fine-grained control over how location works, even in Android 10, Android had decided to split the permissions between a foreground and a background access. So there was an option in the permissions prompt to say allow while in use and allow all the time. So allow all the time was similar to was the equivalent of asking permission to access the user's location while the app was in background. So Android 11 now takes this a step further. What it does, it actually enforces this pattern. And what I mean by enforcing a pattern It means that you now need to make sure that you first ask for foreground permission, and once the foreground permission has been granted to you, you actually ask for the background permission. So this becomes an incremental process. How does that look in practice? You would first ask for foreground permission, and nothing changes in that aspect, right? We were already asking for foreground permission earlier. It's exactly the same thing. But notice here that now I'm just requesting for foreground location. I'm not requesting for background because now the expectation is that this is incremental. You can first ask for foreground, and if the user grants you foreground, you will then ask for background permission. And what this really means is, unlike in Android 10, now there is no longer an option for users to say, hey, grant this app foreground as well as background permission. So if you see the dialog no longer has allow all the time. So if you're saying, as a developer, I'm saying, hey, I need foreground and background permission, what Android would do is it would first show a dialog that says, hey, this developer or this app wants to access your location. And the user could say, okay, allow them to access my location. Then the Android will prompt another dialog saying, oh, they also want to access background location. Do you want to grant them as well? At this point, there is no in-app way for the user to grant location permission. So previously in the dialog itself, there was an option saying allow all the time. That's no longer the case. The user will have to go to system settings, which the system dialog will deep link to. The user will go to the system settings, and inside your system settings, there's an option to grant your permission, a background location permission all the time. What this does is makes it the permission grant more explicit. Like the user, it's explicitly going to the operating system dialog and saying, hey, allow this app to access location permissions all the time. Also note, at this point, the user can choose to deny this location permission. So even if the user earlier granted you foreground permission, and because of the background request, it goes to the explicit system dialog, there's still an option to deny over there. So the user could completely deny you the permission and come back to your app, and again, like, you should always check the permission again. Do not assume the cache state. This new permission, unlike the one-time permission, actually takes into effect if you're targeting Android 11, that is the API level R. So if your app is not targeting API level R or 11, but is installed on a device which is running Android 11, then it's slightly different. Then, because earlier you were still used to asking background and location foreground permissions together, the system has a backwards compatibility option for such apps. In this scenario, what would happen is the system will show an extended dialog. So instead of showing two dialogues, the system shows one dialog, but there's still no option to say allow all the time. It's just now this extended dialog explains to the user that the user needs to go to the system settings and give you the background permission. So even if you do or do not update your apps to Android 11, well, you would update your apps to Android 11. So before you have actually updated your apps to target Android 11, there's just a slight difference in how the prompt for location access is granted to the user. The behavior is actually still the same, that the user cannot grant background location permissions in app. The user actually has to go to the system settings to really grant them to your app. Okay. Next up, staying with the concept of permissions, there is a new concept called auto reset permissions. What auto reset means is, let's say your app has not been used by the user for several months. A lot of users install apps and they just keep it on the device. Like they use it one time or they use it multiple times and then they just forget about it. But it's lying there sitting on the user's device, probably gaining access to some dangerous permissions that was granted by the user because that one time the user actually wanted to use that app. So what Android 11 brings is a concept of auto reset. What would happen is, if your app is not used for months, let's say for several months, the system will reset your app's permission. And this is very similar to user going to system settings and explicitly revoking the permissions that were granted to your app. Now, just that the system would do it for the user. Again, at this point, you don't need to worry about any change, this impacting you in any impacting us developers in any way, as long as we were following the best practices, which implied that you should uh, check for the availability, check for the grant of the permissions before you enact on them. So again, like a lot of emphasis this time around has been, if developers were following best practices that were detailed over the last couple of years, these changes are mostly to benefit the users rather than impact developers. And this change is only happens if your app targets Android 11. So if you haven't yet targeted Android 11 and your app is running on an Android 11 device, your permissions won't be auto reset for you. When the permission is actually auto reset, the system will inform the user through a notification. So the user is aware that this has happened. This allows the user to go in and take an action if they feel that no, this app needs the permission. And one of the most common questions that I've seen is, what if my app is primarily supposed to work in the background? Maybe your app is a smart device connectivity app, or it's syncs the user's data in the background. So if the user denies permissions to such apps, it might not be it might not be great for your entire app experience, right? Because you expect this to just transparently work in the background forever for the user. So for this, Android has you covered. What you could do is, we could actually send an intent with the settings action application details settings flag. This intent will actually redirect this user to the system settings, where the user can go and say, hey, do not revoke the permissions for this app. I am aware that I've granted these permissions, just don't revoke it. So if I just move back a bit, this is the dialog. This is the what the system settings look like. By default, your toggle to revoke permissions is on, but you can actually redirect the user to this screen. Like, you can first educate them and then redirect them to this screen to let them know that please disable this option so my permissions aren't revoked, as I will continue to work in the background for you and perform actions. So I consistently need this permission, because you're a background app and the user might never really open you to the foreground. So the system might feel that this user hasn't really used your app in over the last couple of months. All right, so yeah, that was a quick tour through permissions. A lot of changes, like on permissions coming in. Some of them can be a bit, let's say, a bit tricky to understand, but I would again emphasize, as long as best practices are followed, actually the permission changes don't really affect the developers that much. Okay. Next up, let's look at new foreground service types that have been added into Android 11. So Android 10 had actually introduced the concept of foreground service types. And what foreground service types meant was, apps could declare their intention to access some private data in a foreground service. And though there were a lot of foreground service types introduced, such as sync, media player, phone call, media projection, location, actually only two of these were enforced. And by enforced, I mean is, if you had a foreground service and it did not specify its service type, they could still continue to access private data without letting the system know the service type, except for two service types, like for location and media projection, such as Android Auto, Bluetooth, TV, etc. Except for these two, like only these two were enforced. Like, if you did not specify your foreground service type as location, you could not access location data for the user. So this is what I mean by enforced. And now Android is extending this enforcing rule to actually also include camera and microphone. So for camera, it's the similar way that you would do for foreground service type for location. Let's say you just have to specify foreground service type as camera inside that, and now your service is able to receive camera information. I think this is an important change for a lot of developers. I have personally noticed, and I've seen a lot in the open source as well, that a lot of developers would create a foreground service to actually uh, boot up the camera or actually warm start the camera before the user is actually going to use the camera. Like if you know, hey, the user is about to use the camera in the next couple of clicks, a lot of developers would kickstart the foreground service to actually start warming up the camera so that when the user actually presses the camera icon, it's really quickly available inside the app. Now that kind of trickery would actually no longer work. I mean, it could work as long as you specify to the user that you're using a foreground service type of camera. So the handset display a foreground service notification to the user that the camera is being accessed. Again, this would come with the caveat that the user is actually not really using the camera right now. So why is this app accessing my camera? So it becomes important to educate the users if you're doing such kind of behaviors. And along with camera, as I mentioned, microphone is also enforced as a foreground service type. And so, and if you have one service type which needs to access multiple kind of information, you can just declare them together. No need to create separate foreground services. I think the Android team completely understands, a lot of time camera and microphone permissions go hand in hand for most apps. So you could create one foreground service and say it needs to access both camera and microphone permission. So important to remember here, if you do not specify foreground service types, this foreground service will not be able to access any private data related to camera, location, or microphone. Even though that permission was granted to you by the user, you need to explicitly mention in the foreground service this type that you're accessing this information. Okay, so now we've covered permissions and foreground service types. Next up, let's look at package visibility. So, since like API level 1 on Android, we were actually allowed to see what packages or what apps are installed on the user's device. So if you ever did a call like this, like get installed packages, system would return you every app that was installed on the device, right? And this was actually like, this is not something which is great for privacy. Like no app should actually be able to see what all apps are installed on the user's device. So Android 11 tries to introduce some changes into how apps can query what all apps are installed on the device and how they can interact with these apps. Now, rest assured that a lot of common scenarios where you need to know what app is installed does not change. Like first, I'll go through some of the common scenarios which really don't change, even though there's some restriction being added on how and why you can query another app that's installed on the user's device. So first, let's look at things that doesn't really change. Okay, so if you're using something like this, where you're passing your own package name, that doesn't change because you're asking information for your own app. So that does not change, right? If you had something like get installed packages, which earlier would return list of all apps, this would now return list of your app, including some other apps, system installed apps, which are necessary for core Android functionality, just such as the dialer, the messaging app. These apps will still be returned to you because these are core system functionality, such as the camera. These apps will continue to be returned. So if you're relying on such functionality, no changes needed for you. If you're sending an implicit intent, saying, let's say you're just saying, hey, go ahead and capture an image for me, and you still use the package manager for it, right? No changes needed because that's implicit. You're not targeting any particular app, right? If there's an eligible app, the user will just prompt the user to select one of the apps. So as a developer, I've not said, hey, use this specific app to capture an image. You're just saying, hey, go ahead, just capture an image and let me know. So nothing changes. If your app calls another app's content provider and expects results, nothing changes as well. You can just go ahead and query and interact with those apps just as you were doing pre-Android 11. So none of these things actually really change. So what exactly is really changing? Actually, what really changes is if you try to query for some specific app. Like let's say you do, hey, I want to know about this specific app. Like, is this specific app installed on the system? Nope, that's no longer allowed. You will get a name not found exception, even though the app might be installed for you. So this is out of bounds now. But there's still some scenarios that you might want to know if another app is installed. Like let's say you work at an organization which issues 3 or 4 apps, right? And you have a way for each app to communicate with each other. So in this scenario, you still need to be able to query for certain apps. So by default, this doesn't work, but there's a new set of manifest entries available where use a queries you can use a queries element in your manifest to specify the list of apps or the list of package names that you need access to. So here you can specify, hey, I know the system is not going to let me know all the apps that are installed, but these packages in particular, I really need to know if they're installed or not. So you have to define this in your manifest. And if you do so, then your get install packages with the package ID would actually let you know if that package is installed or not. And you can specify multiple, not just one. If you need to know all the apps that are available for a certain functionality, such as, a lot of apps build customized share sheets in their app. Like they don't want to use the system's default share sheet for sharing some certain content, right? So you can also specify intent filters in your queries filter, saying, I want list of all apps which can handle this intent. So that's also another way to get a list of all the apps. So as you're seeing, we're allowing you, Android is allowing you to filter down the list of apps you can access instead of saying, I just want to know blatantly all apps that are installed on this device. So in your case, but let's say you somehow really need to know all packages. Like your app has some specific use case in which filtering down to specific apps or certain intents don't really work for you, and you need to know all list of all packages. There's actually a new permission available called query all packages. You can add this to your manifest, and then it will be possible to query list of all apps. But be careful that if you publish such an app to Play Store, it will be reviewed and restricted under a Google Play policy, and the new policy guidelines around this should be out soon on Google Play. I think they came out 2 days ago. I didn't get a chance to go through them. So you could probably have a look at the new policy guidelines on Google Play, which explains how what are the criteria under which they will allow publishing of an app into the store which wants to query all packages that are installed inside the device. So just keep an eye out for that. Okay, quickly, I'll just go through some of the common use cases which also doesn't, because of the package visibility changes, some common use cases which can be made better now with new flags available. So currently, if you are using such kind of a code in your app where you're asking system to open a activity which can handle this URL, what system generally does it shows the user a dialog, right? Do you want this to be handled by this app or the browser? But as a developer, I might feel that, hey, this is a really bad experience. I just want user to go directly inside the app, which can handle it. So what you can do is there's a new flag which has been introduced called flag require non-browser. And what the system would do is the system would check internally that, hey, is there an app which can handle this intent? And if it does, then the system will just launch that. This goes hand in hand with the package visibility, because now when the package visibility changes, you cannot really query, hey, is there an app which can handle news.google.com, right? Because you're no longer allowed to query for apps, right? So the system will always return name not found. So this new flag will make it easier for you, because a lot of developers, what we would do is we would just do a try catch and we would check activity not found exception. And if it isn't, we would start to launch the browser, right? Otherwise, we would see if there's an app which can directly handle this. So now you don't need to go through all of that pain. You can just say flag require non-browser. And if there's no browser installed, if there's an app which is not a browser, which can open this deep link, the system would do it for you. But what if there is no app installed and only browser can do it, then it's the same scenario that the system will throw an exception. You handle the activity not found exception and then go ahead and display it in a Chrome custom tab or pass it to the system browser to handle it for you. Yeah, so an activity not found exception is thrown in case there's only a browser available. Okay, next up, data access auditing. Actually, I would say this is one of the really cool features that have come out in Android 11, like one of my personal favorites. This is for, so a lot of times in a lot of apps, we request for users data, but sometimes your teams are so big, and what happens is your team becomes so big, you have a lot of people who join the team and then they leave, and then you have often code which you can't really understand. Hey, why is this code accessing this kind of permission, right? Or let's say you have a third party SDK, and these SDKs are accessing users private data without your knowledge, like because your app has a functionality request for some private data that you want to access. Somehow the third party SDKs decide to piggyback on this information being available, and they also uh, access this personal information of the user, even though you did not intend to give it to the third party SDKs. So how can such kind of access patterns be restricted, right? We don't want third party SDKs or some random code in our code base to actually do it without us being aware, because it's an orphan code base. In large teams, that is a good possibility to happen. So Android 11 actually introduces this possibility. There's a new API which allows you to set up data access audits. What would happen is, let's say you have spaghetti code all over the place, accessing these individual uh, data which fall under users' dangerous permissions. So what you could do is, there'll be two new APIs. One is an API which lets you know that at what point in time did my code access this, my code or anything which is inside my app. At what point did I access this private location? So, oh, sorry, this private data of the user. So it will give you a callback to let you know, hey, this private data has just been accessed. And so first, let's look at how this private data access would work, like how this callback would work. So let's say you set up there's a new app ops manager service. You get that instance out, and then you set up a callback on that for data auditing, right? And this will let you know, so that your app ops callback will actually be called whenever any part of your code actually accesses this private data. And it is called before the data is actually returned to you in that random part of the code base, right? At any moment where you access this data, they'll let you know. And because now you know the exact location of where this uh, request was made, you get it. So it's actually like a stack trace, like just like we have for crash logs, you get a stack trace of where this event or where this crash happened. Just like this callback will actually have the stack trace of a certain piece in your code telling you that that part of the code or that part of the third party SDK's code actually triggered an access to a private data. So now you can go ahead and log this information in your analytics tool and see what actions you might want to take, or check that this is in line with what you expect, that I expect this activity or this fragment to actually be accessing this location, and this is this permission or this data, and this is great. But sometimes you might see, hey, this random piece of my code is accessing private data. It shouldn't do it. Like, I don't expect that to be the case. So such kind of logging will really be helpful for a lot of apps. And if you want this to be available for your entire app, you can set it on application on create. If you want it to happen at the activity level, you can actually just set it on activity on create, or take it even further. If you want to do it at the fragment level, you can do it in the fragment code. Okay, but sometimes just getting stack trace information, like the previous example I gave was how you can access it via stack trace. And sometimes getting access to stack trace is actually not that sufficient. what you would want is you would want to be able to tag this to certain features in your app. Like let's say you're like, hey, I know this line of code is accessing this private permission, but I actually want to attribute it to a feature. Like let's say my app has 4 features and I want to say, hey, I just want to say that this is the find friends feature, which is accessing this kind of permission. This is the navigation feature, which is accessing this kind of private data. So you can also do that with the data auditing tools that have been introduced. And how I personally feel this really helps is, like, let's say you have a find friends feature in your app. If you can attribute private data access to features, it should actually eventually tell you that the find friends feature is actually only using location and contacts data, for example. It's never using the microphone. So it also helps, to audit that our features are working as we expect them to work. Right? And similarly, just like we looked at the app ops manager, here's a quick snippet. You can create an attribution context, so which in which you can give the feature name, and then you can pass this attribution context to your app ops manager and say, hey, this is my attribution context, and whenever a private data has been accessed, the app would whenever the app would call you back that this private data was accessed, they will give you back that attribution tag or attribution context that you had passed it to that during the creation of the app ops manager. So that ways you can always see that, hey, I'm in the find friends activity. I created a find friends attribution context. Then in your global handler, you will get back this attribution context and you can match and see, okay, this was the find friends feature, which actually used the location permission, and that's completely okay. All right. Okay. So the final changes, let's look at them, is scoped storage. This was actually introduced in Android 10, but it was optional. You could actually opt out of scoped storage changes and say, hey, there was an option to say request legacy storage and say, hey, I'm not yet ready for scoped storage changes. They were really big, and a lot of developers were not really prepared to adapt to this new broad set of changes which were introduced in Android 10, like because it started to classify the storage into 2 buckets. You had an app storage, you had a shared storage, and storage permission only gave you access to one of them. So this really changed a lot in Android 10. So a lot of developers said they did a temporary opt out by saying that, hey, I still want to work with how legacy storage worked. But now in Android 11, that's no longer the case. So if you have a storage based app, scoped storage is now compulsory in Android 11. So first of all, this means that if you're building apps for Android 11 or you're updating your target SDK, scoped storage is enforced. So that is the first thing that we all have to do. Target Android 11, adjust to the new world of scoped storage. Also, there are a few little tweaks in how scoped storage used to work in Android 10 versus how it works in Android 11. Actually, now it's actually been renamed to files and media. So so the prompt is no longer going to say allow your app to access storage. It will say allow this app to access files and media on this device. I think this just makes it a lot more explicit for the user, so that the user is a lot more clearer on what kind of information that this app is capable of accessing. Uh, Also, earlier in scope storage in Android 10, we saw how if you are a file manager or a app which is accessing user storage and you want to edit some file on the user's device, uh, you need to get permission. Like you need to get explicit permission for each file, as long as that was being each file that you wanted to edit that did not belong to your app. So if you're editing such kind of files, Android 11 just slightly improves on this process. Instead of asking you to grant permission to each individual file one by one, what you could do is you could now request permissions for all of these files in one go. So as you see here in this code snippet, you can see that you can create a list of all the files. and you can request access for them in one go. So the system will bunch them together instead of prompting them one by one. Hey, give permission to file A, give permission to file B, give permission to file C. That goes away. You'll have one consistent dialog will say, give permission to all these 10 files. So it's just a slightly better user experience and needs a few tweaks from the developer side to request them together. And once the permission is granted, you can go ahead and take your required action. Next up is a few restrictions that have been added onto the intent flags, staying in the theme with scoped storage. Earlier, if you would request, like open a file manager, if you had a file manager or you open a file manager with action of open document tree, the user could select files in any of the Android document tree, but that's no longer the case. In Android 11, they can no longer access anything inside root, downloads, or the Android data and Android OBB folders. These are now private, and your apps can never access what is inside this. If you instead opened it with action open document and not use open document tree, then you can get access to download, but you still cannot ever get access to Android data or Android OBB. These directories and subdirectories are completely off limits beginning with Android 11. I mean, also again, like staying in theme with the best practices, again, this shouldn't really matter. I personally never saw a use case why anybody would need access to information inside the data or OBB folders. But in case your app had a reason to do so, sorry about that. Yeah, in case your app had a reason to do so, that's no longer the case with Android 11. Right. But again, just like we spoke about package visibility, like in package visibility, we talked about if your app really needed access to all packages. That's still the same case for external storage. Like, what if your app really, really, really needs access to everything on the storage? Even the downloads folder, even the Android OBB folders. Like, let's say you're a file manager app, right? And in that case, you need access to all kinds of apps on the all kind of files on the user device, or you're a backup and restore app. This should still be feasible. Like, you can still declare the manage external storage permission, but just like package visibility, there's a Google Play policy which came out a couple of days, which lists out the set of guidelines and procedures for how you could publish an app into Play Store with such kind of permissions. So as long as you meet that policy guidelines, it should be okay. So have a look at that policy guideline, and that details the next steps to follow. Okay, and just a few more important changes that are introduced in Android 11, which are kind of similar to what which are around privacy. First up is read phone state is now a bit restricted. Earlier, with read phone state permission, you could access if is the phone ringing or not, and you could also access a bit more private information such as user's phone number. Like, this is a private information. That's no longer the case with Android 11. So if you target Android 11, there's a new permission called read phone numbers, which is needed to access the phone number of the user's device. So you can no longer access that with read phone state. So inside your app manifest, you now need to specify, as I mentioned, the read phone numbers permission, which will come into play on Android 11 and above. For anything which is Android 10 and below, yes, you would continue to get phone numbers even with the read phone state permission. Also, a few more restrictions on MAC address. Apps can no longer access MAC address for network info. So yeah, if you were using Mac, I think MAC address has been clamped down since Android 9, if I'm not mistaken. So yeah, by now, a very few apps out there should be who are still needing access to MAC address of the user for certain use cases. If you still need them, do reach out to the Google support teams to let them know your use cases. System alert window was removed in Android Go devices in Android 10 anyways last time around. Now it's getting more restricted. So if you have an app which needs system alert window access, earlier what you could do is you could actually ask for this manage overlay permissions. And what this would do is you could actually direct the user to your app inside system settings, where the user could go and say, hey, okay, give this app the permission to draw an overlay window. That's still possible, but now you can no longer deep link inside your app in the system settings. It's again like keeping with the theme of making the grants more explicit, just like it was the case for background permission. It's more explicit. You can only deep link user to the generic list of all apps on your device. Then the user has to look for your app and go ahead and grant permission. This is more about clamping down on access to system overlay windows. Bubbles is a good replacement, and I think the next talk will cover a lot into bubbles and how that could be a good replacement for your system alert window permissions. Okay, adapting to these changes, like there's a lot of changes introduced, right, on Android 11. Some of them will target your app even though you update the target SDK, and some of them will target your app, like will be applied to your app even if you do not update the target SDK. So to make this work easier for developers, Android has actually introduced a app compatibility option inside developer settings. So if you go to developer settings, enable there's a section called app compatibility, which will show you your app. And for your app, you can enable specific like there's a UI which is available, which you can use to toggle specific features on and off. Like you could be like, oh, enable external storage for my app, enable scope storage for my app, and see how your app responds, even though you haven't updated your app to Android R, right? Because like currently the way for you to test would be, hey, update to Android R, test your app and see how it works, and realize, oh, it's broken, let me roll back and not push out updates to Android R. What the compatibility framework does is you can say, hey, I'm not yet targeting Android R, but I still want to see how my app will work, right? And because you're not targeting Android R, these features are not affecting your apps right now. So you go to app compatibility and say, okay, auto reset permissions. I know I'm not targeting Android R, but enable that for my app right now so that I can test how this works. So incrementally, you can test one feature at a time without updating to Android R. And once everything works, go ahead and update to Android R. So you can take a good amount of time. You can be like, okay, I fixed permission issues in my app and I've issued an update, but I'm still not targeting Android R. But I fixed permission issues because I use app compatibility framework to do this for me. If you're not a fan of going to developer options and doing it, there's an ADB command available as well to do these changes for you. Uh, yeah. And lastly, I would like to mention how the compatibility framework works. It only works for debuggable apps. So you can rest assured that if you have a production app installed on an Android 11 device, the user cannot go like, oh, enable auto reset for this app, because your app doesn't target Android R. So the user cannot do that. This is only and only available for debuggable apps. All right. Okay. Yeah, that's it. To wrap up, a lot of privacy changes have been introduced. Majority of them do not take place unless you target Android R. Uh, Most of like majority of the changes in terms of permission, package visibility, they don't need much changes on you developers part, as long as we were following best practices. And for other changes, or in case there's something which breaks in your app, you please use the new app compatibility framework inside developer options to test out these changes, see how they impact you. And yeah, that's it. Get your apps ready for Android 11. That's it. Thank you.
Thank you, sir. I guess in the comment section there are no proper questions right now, but later on, I guess after this recorded session gets put up on YouTube, people might start commenting questions. So I hope you spare some time in answering their questions.
Sure, sure. I'll keep a lookout for them. I'll keep them.
Hello.
Yeah, I can hear you.
Yeah. So thank you, sir, for So coming up next, we have another speaker who's Brijesh, and he's a lead Android engineer, and he's going to be talking about the new stuff in Android 11. So, hi, sir.
Hi, hello, good morning.
So, you can
Cool.
start.
Okay, I'll start. Hello, everyone. My name is Brijesh. I am a lead Android engineer at Byju's. So, apart from doing Android development there and taking care of team, I do organize meetups in Bangalore with a GDG group called BL Android. Yeah, so today we'll go through about what's new in Android 11, what are the new user-facing changes, what are the new changes for developers, what are some other restrictions that will come up when you are developing the apps with targeting Android 11. So we'll go through like tools and libraries, what all Android has introduced new, and also the user-facing changes. So wait, one second. I think, is it better now, the voice? Can you check?
We can hear you, sir.
Okay, nice. Okay. So first we'll go through UI changes, which are like, as you know, like when Android 11 release comes out, all the users will be looking out for UI related changes, which we can, they could see. And so from developer side, one of the biggest change that you will see in Android 11 is a window insets API. So what window inset means is that what is system rendering on your screen basically. So to account like there are status bar, there are navigation bar, the IME can come up in your screen, and then your app has to adapt to these things. That if it is in full screen, if a user shows up, navigation bar from the bottom. So what happens when those changes do, like system does those changes, and you have to react to those changes. So until now, it was very hard to get understanding of where is keyboard visible or not, or how much area the status bar and the navigation bars are occupying. So those APIs are very confusing. People flag that you would use, but what if you use those in combination? What happens? So there are a lot of confusion. So in Android 11, they cleared up a lot of things, and now those are much simpler APIs which you can utilize and adapt your app based on the system changes of Windows. So what you need to do these changes is there is an set on apply window inset listeners. So get that listener applied to the view that you are currently showing in your screen, and you get the insets. From that insets, you can query that what all things are visible. So here, as you can see, I got the insets from the callback, and I'm seeing is my IME type visible. Like this was very hard previously. If you have ever tried working with this API, it was not this straightforward. So now you can just query it that if your IMA is visible, and based on that you can make changes like you can readjust your screen size if you want to hide or show something, and just get the user focus on the text field which brought up the IME. So to go more in detail, there is a nice blog by Mark Ellison. So I'll show you some of his screens so you can understand easily that how this API can help you. Yeah, so this is a screenshot from his demo app. What's happening here is the X part that you see, that is the area where you can render your application. So in the first screenshot, if you see, you are able to render behind the status bar of the battery indicator and all, and it's also IME visible. So you see that X is ending on top of IME. So basically, exact area where your application can show view. So and right side, if you see, I have just done system bars. That okay, I want to ignore system bars. I just want to draw it, within the visible area. And these are now very simple APIs. Mark goes through in detail with all those things. There's a GitHub demo for this app also. So I'll just share the link. You can just search stylingandroid.com. That's where he blogs about all this UI related stuff, latest and greatest thing that comes in the UI. He does a very thorough job of getting you through all the examples and demos. So yeah, this is the demo app that you could see there. Cool. So, what else does this Inset APIs allow us? So, one of the major thing it does is that it can now we can now do have animations based on the IME visibility. So, what does that mean is you can when the keyboard is coming up, you will get a callback. and you can handle your applications with an animation. Like if you want to hide some things or if you want to scroll up, so that you can do with the information of the system, that okay, the screen like IME is coming up and this is a callback, this is how much area it's occupying currently. So you can synchronize your animations, so that currently what happens is sometimes, let's say there's an app, you click on a text field and keyboard like suddenly comes up. There's a jerk that the screen starts to adjust, and gets a focus on that text field, and the keyboard comes up suddenly. So there's a jerk if you see current applications. But if you are with these APIs, it will be very easier to adapt those the screen changes rather than just showing it in a flicker. So you can listen for the changes, you can synchronize your animations. I'll show an example which Chris Baines has created. So yeah, the left side, if you see, uh, it's using a callback method. So here you will just get a callback that the screen is getting visible. You can just have a slight transition of the views. And but there's one more way. On the right side, if you see, user is focused on that keyboard and he's just dragging the screen. So the keyboard, since the focus is on text field, the keyboard is gonna come up, and like it's very smooth transition. You see the top content, it's slightly moving out of the screen, rather than suddenly disappearing and showing a jog to user. So we'll see how to do that. So for that, this is a code that you'll have to use to get the callback. So what's happening here is, on edit text, there we can set a set window inset animation callback. So once this animation callback is set on an edit text, whenever there's a focus on that edit text, you will get a callback. That okay, and these are the four methods that you will have to, or you will get information out of. So the main is the first one, that on progress. So it gives you the window insets, like okay, the screen current, like this is how much screen is going to be occupied, and this how I'm showing the keyboard. So this is pretty good if you are like if you have a keyboard related fields in your application, and you want to have a nice transition rather than the jobs that we were facing previously. And the second one, the sliding animation thing. So there's a window insert controller. So in that you can set this control window insert animation, and there you will see that okay, which IME is coming up. The time so system will tell you that it's animating. Keyboard is animated, and this is how much currently it's visible because it's sliding in slowly. So frame by frame, you will get the callbacks, and then you can use that scroll and drag movement. You can track and do animations accordingly. For this also, the code is available on the GitHub. You can just go to this link. So insert animation sample is available, and you will see all these code changes there. So it will be easier for you to understand and play around with it. After this, we'll go through one more big change that users will see affecting on their side immediately when the Android 11 launches, and it's called conversations. So this is actually pretty good change if I see from the user perspective, because what happens now here is that your notifications are separated out from the conversations that you have with people. So messaging app can now do some following changes that I'll go through in Android 11, and then these changes will let them show their notification in a conversation area rather than a notification. Because what happens is, like, we have 50 to 60 apps, like everybody has a lot of apps installed in their application, and everybody wants to show some notification. So all the apps will be fighting for that notification area, that hey, there's an email, hey, there's some parcel that is getting delivered, hey, there's a spam SMS coming in, there are some email spam that are coming in, some apps are updated and whatnot. Like, we see a lot of notifications per day on our phones. That within these notifications, sometimes our conversation get missed. So that's what the Android is trying to solve here, is that your private and personal conversation should come up in the conversation area, so you can focus on that. And if you want, the notifications are still there below. So there are two separate areas now. The other thing that it provides is changing the priority on the notifications. So if you have some close friend or family members, in this case it's a school messages, so you can just change the priority or to it, like make it silent alerting or priority. So if you make it a priority, then it will show up on top of the conversation list only. It will still stay in the same area, but it will be on top of it, so that you have all the controls here in conversation area to silence somebody or still make it a higher priority. Now, how what all are the changes required for this? So to make it conversation, first you need to build a person. So everything revolves around person here. So you create a person, and then you create a shortcut info builder. You create a long live shortcut using this. So in this shortcut info builder, you have to pass that person builder that you created and mark it as long live. So long live is something which tells system that this is a long lived shortcut, and it keeps track of all these shortcuts, and it's easier for user to come back to the information afterwards. So you just build this shortcut information, and then using the shortcut manager compact, you push this shortcut to shortcut manager, so that it's aware of the shortcut related information. And next thing you have to do is you have to create a messaging style notifications. This is for everybody who is like who wants to put their notification in conversation area. So you have to create a messaging style conversation and add your messages and all other info that you have, the user avatar and everything. So you create a notification out of it, and then in notification compact builder, you pass the shortcut ID. From shortcut info, you can get the shortcut ID, and you can pass it here, and you just build it. So this is how you will be able to show your notifications in conversations. So as a developers, we'll have to be focused on what thing goes into conversation and what thing doesn't go in conversation. Like if it is a bot related message, like let's say there's some let's say for WhatsApp kind of thing, that your backup failed or it's backing up the information, it doesn't have to go in conversation. So when you are creating a notification and marking it as a conversation, make sure that it's relevant. It's like one-to-one information, or it's important. It should not be a broadcast message or an update message or status message that goes to conversation. Then it will lose its purpose. So just one-to-one direct user communications should go to conversations. Next thing around conversations, shortcuts, and notification is thing called bubble. So if you have ever used Facebook Messenger, then you would know that they are floating. They have a floating icon on top of all the windows. So currently, it's not supported with the system API. They're just using system window alert and trying to draw activity on top of it. And it was a very hacky way also for us to do, and it was not a streamlined way. But since there are a lot of use cases to show a bubble kind of thing floating on your screen, and like a lot of apps wants to do it, and there are browsers that does it, there are chat mess applications that do it. So now Android has come up with an proper system APIs. So now notifications can also show bubbles. And Android 10 it is there, but it's in developer options. Not really everybody goes there and enables those, and it was still in like development. But now they are here finally. In Android 11, everybody can use bubbles. All the app developers can utilize it, and there's a pretty nice way to pop out a conversation to bubble. Also, I'll show you in detail. Better than system alert window. Obviously, a proper API is always welcome. Then hacking around system and trying to achieve something, and then it breaks on another 10 Android platforms. It's part of the notification API. You just have to pass some more metadata and a dedicated activity to do that. So we'll see how like from the conversation you can create a bubble. So whenever you have a conversation and you are passing on the bubble information with that conversation shortcut that we just created for the conversations, like couple of screens back. So here, what is happening is they see this the latest conversation. It's not in bubble before I pop it out. So as soon as I get a message and I see that okay, I want to like put it in a bubble and I want to reply it while using other applications, or some conversation is going on, but I don't want to go to that app and do it. But I don't know, multitask basically. So you can just press that icon next to the conversation API, conversation UI, and then it pops out as a bubble. So what are changes you need to do for the bubble activity is we'll go through that. So in your manifest, you have to mark it as resizable activity because your bubble, based on your screen size, it occupies like some 70-80% of the screen area. So the activity has to be recyclable, whichever wants to pop it, like show it in a bubble, so that it's like Android system can resize it basically. And it's basically a mini activity that gets launched when user taps on bubble. So, like a normal intent, you pass a context and a bubble the whichever activity you want to show, and then you get a pending intent out of it by creating a pending intent or get activity, and then you have to create a metadata. So this shortcut is something that we created just now for the conversation thing, and so that shortcut ID you need to pass to bubble metadata builder. So notification class has now a bubble metadata builder class, and you need to pass that shortcut ID of that conversation to this. And with the shortcut ID now, you just have to set bubble metadata and set this bubble metadata to the notification builder. So this is pretty much goes along with the conversation API which we created. So just pass that bubble metadata, create a messaging style notification, and shortcut ID we were already passing. Now we are passing a metadata, and that's it. This much code will show that bubble icon next to your conversation, and user can pop it out whenever they want. To know more about bubbles and how they ended up making an API, or what all information went inside to create bubbles and what are challenges they are facing, there's this nice podcast on it. It's called Android Backstage, and there's an episode on Android Backstage about whole dedicated about bubble. So where bubble team, like Android system team, talks in detail about how they're doing it. So if you're interested more in the details, you should see that Android Developer Backstage podcast. So it's run by Chad Romain and Tor. So they usually take the system APIs and go through in detail of those. So privacy is main focus in Android 10, 11, largely. Like we have runtime permissions since the Marshmallow, but after the word, so there are a lot of fine-grained things that they are doing on privacy side, and Saurabh just went through a lot of those privacy changes. So I'm not going to talk about it, but yeah, privacy is a major thing now happening on Android. With every release, they are figuring out more and more ways to restrict make the system stable, and make it less prone to misuse basically. So this is what our users will see and interact directly with. But what about us? Like we are developers, and we need something great with every release, right? Because there are a lot of still pain points while developing Android apps. So to make it easier, there are a few features which are targeted for developers, and the first one out of it is Wi-Fi debugging. Like currently, it's very hard to get a cable and then start debugging. You have to connect that cable. There are different types of USB B, USB C, and whatnot. Your laptop stops supporting USB ports, and now you have to buy converters and dongles, and it's a lot of a mess. So, like, this is how a normal typical Android developer laptop might look like. That you want to connect the screen, you want to connect the keyboard and whatnot. So to get away off all this, now we have Wi-Fi debugging. So this was there in Android, but what happened was in that you'll have to like connect it once, and every time you want to start using it. But if you could connect it, then you would use USB, right? So what happened? So this is a new way to do Wi-Fi debugging. If you go in your settings, you'll see your IP. There's a separate wireless debugging screen in your developer options, and uh, in Android 11. Sorry. So you see a Wi-Fi address and port displayed in the setting screens, and you just have to go to your ADB command and just fire this. So it directly connects it to the Wi-Fi. You don't need to connect via the cable once. It directly goes to the same Wi-Fi if you are there, and then it just directly connects. Second thing is nullability annotations. So this annotations are very useful when you want to, is let's say you are developing an SDK, or you're developing some part of your code which other developers use it. You're developing one screen which other developer in your team will be calling it, and passing bundle information or some method which utility method. So in Android system, they have introduced a new annotations called recently nullable and recently non-null. So how it differs from normal nullable and non-null is that it shows warnings. So current, because like it takes time for us to adapt new changes that comes with releases, right? So if you directly break it up by making it non-null, then if you are passing null somewhere, it will throw errors when compiling its application. So if you're like, that's why they introduced this recently nullable, that this will throw warning for this release, and then slowly they'll phase it out and make it nullable and non-null directly. So this helps us in figuring out that, okay, this is some part where I need to start looking for my application, and within few releases it might start breaking things. So this is a nice way for them to give us warnings, and for us to spare some time and figure out how to handle those changes. And you should definitely use in your normal code, you should definitely use nullable and non-null annotations wherever you can. So it helps very much that while working itself, the developer can figure out, okay, I should not pass null here, or okay, if it is null, the method is handling it. I don't have to worry about it. It's doing null checks internally, and it will not crash. So I'd highly recommend using for yourself also in your code nullable and non-null. Next thing is crash reason reporting. So at times what happens is our app crashes, and when it crashes, you don't have any way to figure out what happened. Like we surely have Firebase crash analytics and all, and they do all this heavy lifting for us, and then tell us in a nice dashboard that, okay, this app, this version is crashing. But what the more information system is adding is for something like ANR. So when activity not responding happens, it's not very easy for even crash reporting services or for ourselves to figure out, if we're not using crash analytics, that what happened, why did my application crash? If it happens in production, you can't ask for logs, and logs are also disabled in most of the cases in our applications. So to get away with this, now there is an API on Activity Manager called Get Historic Process Exit Reasons. You pass your package name, and that's it. You get a reason for crashes, and you can loop through those reasons and figure out, either you can log, you can store it in your data, you can upload. So if your application crashes because of low memory, because of ANR or some other system related things where your app had to exit, now you can figure out those. And mostly like some crash analytics kind of service will come up with a way to utilize this, and then we might not have to use it directly. But as of now, if you want to use, system is now giving all those information, that why your app crashed, what happened, apart from a normal stack trace. This will be very helpful to figure out the crashes in production. The next thing is ADB incremental. So it's a way to install your APK faster on the device. So any device that's running on Android 11 and Pixel 4 or any other devices which comes up with Android 11, we can use ADB incremental, and we can install our APKs faster. So this may not be like very helpful for apps that are like 10-20 MBs, but think about games. Like there are games which are 2 GBs or 4 GBs game. So in those cases, this is a very helpful way to install application faster, because let's say they change, like let's say changes a couple of things in their application, and they'll have to wait for a 2 GB file to transfer in a device. It takes too much time. So to give a comparison, like if it's a 3.5 GB application on a Pixel 4 with USB 3.0, ADB used to take 68 seconds, and now ADB incremental takes just 7 seconds. It's like 10 times faster than the previous one. So for this, there's some minor change that applications will have to do, but it's going to save a huge amount of time for them to install it. and just get things see on device very faster. It's always nice. So what they have to do is they have to adapt to an alternative signature scheme. So there's a signature scheme V4. They'll have to make their app sign with that signature instead of the normal V2 or V3 signatures. And while installing, they just have to do ADB install incremental. So instead of just doing ADB install, just pass minus minus incremental and then your APK path, and it will install the build APK faster. Mostly it's the playable part that it will install, and the assets and all you can transfer later if those are not changed. So this will be very helpful for game developers. There are some other behavior changes. So every release of Android comes up with this changes which are effects on apps running on that version or apps targeting that version. There are two things. So let's say you run your application on Android 11, there might be some changes that you have to adapt. Otherwise, your app will start breaking. And for that only, we have like developer previews and beta releases for us to figure out. And if Android team has missed any use case where you need those APIs which are changed on particular platform, they run these feedback channels. You can contact your GDGs and get the information passed to Android team that hey, this is breaking for me, and this is use case you might not be aware of. They do, even the Android platform team does of this. Ask me anything on Reddit, which I'll talk about later in my slide. That there are still two AMAs scheduled for us to go there and ask them that okay, hey, you changed this, but this is how I'm using it, and you may not be aware of this use case, and could you give us some more time or like give us a waiver that you keep using it. So, but in Android 11, so they have tried their best to make most of the changes limited to if you target Android SDK R rather than the Android apps that are running on Android 11. So, hopefully, most of our applications should work fine. Uh, so, to change and test those behaviors, let's say you want to still figure out what's happening when you like before targeting Android R, you want to see what happens. So the like Saurabh discussed, there's a command line. There's a tool in developer option, and there's also command line ADB commands that you can use and toggle the behaviors of system. Let's say you want. So this will help you in figuring out the changes which are particular to that area. So, okay, I'll give you an example. So, let's say Android 11 comes up and you run your application, target your application to Android 11 and run on that Android 11 device. What happens is at one time you will see all the changes. So sometimes there are changes that might be affecting something, right? Let's say the storage change can affect the way you use your application. So you will not go through that feature of your application because of other changes also. So what good thing happens here is you can toggle it, and now you can just test your application in silo. That okay, I'll just enable storage related changes so that and disable everything else. So those changes will not get affected by your application when you're running it. So that you can just focus on that particular change and figure out that is your application breaking with respect to storage or not. So this would be a very nice way to test your applications and figure out if there are any breaking changes. Moving forward, there are some graphic and media related changes introduced in Android 11. One of them, which might be useful for a larger audience, is HIF files. So HEIF is an animated file like our GIF files, but a very lightweight and much faster. So now Android supports HIF file natively. With Android 11, you can load your animated images from HIF file. So there's this animated image drawable, which will be able to load your HIF files. As I said, it's very similar to GIFs, and but it's very small in size. So how do you do that? Is first create a file out of your HEAP file and pass it to image decoder. So image decoder is something introduced in few releases back of Android that helps us instead of using bitmap factory, we can use this image decoder, and it provides a nicer API also and a lot more functionality and features to do your image processing and all. So once you create the once you create a source out of your image file using image decoder, The next thing that you have to do is decode that drawable, and you should perform this off main thread. Otherwise, your application will start lagging, and you might throw in ANR also, depending on the image size and the decoding it will require. So do this off thread, and then get this drawable decoded out of your main thread, and then if it is an animated drawable, you can just do a drawable.start. So your animated drawable will be loaded and started. And the next thing is if you're using any OpenSL ES library, so that is deprecated now. So there's a new library called Obo, and it's unbundled C++ library. It's basically you can include in your application. It's not part of system, and it gives basically high performance audio and works backward portability to 16. It's an open source, so you can go to GitHub/Google/Obo. If you are working in audio related applications and audio processing stuff, you should check out this library as well as the Backstage podcast, episode 135. So all these big major changes has the dedicated episodes that you could figure out from Android Backstage, and go deeper into how those things were decided, what was the thinking process behind it. Next thing is variable refresh rate. So what happens is currently, like 2 years back, let's say all the devices were coming up with 60 frames per second refresh rate. So that gives us roughly like 16 milliseconds of time to you know render our screens and finish it logic that we want to run on main threads. Otherwise, what happens is if you take more than 16 milliseconds to run your application logic on main thread, user will start seeing the lags. Like your application will start skipping frames, and user will see that there's a visible difference. That when you scroll some applications, you see that it's jerky, it's not smooth. So sorry, yeah, so those was 60 frames per second. But now there are Android devices which are coming up with so 60 frames per second used to be given. Now there are some devices which are like 90 hertz and 120 hertz. So now you even get more lesser and lesser times with 120 hertz. It's half than what you used to get. So now this after these devices have introduced, let's say you still want to stick to 60 fps, that you have some application which is not able to cope up with 120, and it's going to be a problem if you don't get even that much 16 millisecond time to do something for, let's say, games and all. So what you can do is you can ask the system that I'm gonna set frame rate and pass the information to that API that I'm gonna stick to 60 FPS. So system will try to their best to stick to the 60 FPS rate. So all these devices have that variability also, like they can reduce their frame rates based on applications which are using. Like if your launcher is if you're just on your home screen, then it doesn't have to render something at 120 fps because there are no changes happening on your home screen continuously. So it doesn't try to refresh that fast. So system has that capability, and in your application, if you want, you can enable this surface.set frame rates, and you can utilize that API to lower down the FPS. Then the next thing is there are indicate thermal APIs. So these are mostly for native applications and games. If they want to check and monitor system like device status, so then react to the thermal issues. So if there is some game you are playing on an older devices which is used a lot, the system will heat up, and it sometimes can exit your application. It sometimes can force stop it or throw a warning. So all those things can be done using thermal APIs, and now they have made it simple to use this thermal API. How it works is like you create a thermal listener, a native thermal listener, and then you get a status of your application that okay, it's gonna shut down, it's an emergency, it's in a critical situation. So shutdown is something that device is too hot and it's shutting down immediately. Emergency is like key hardware components are going down and your app must like your app is likely to misbehave or stop functioning, so you should like save a state or go to sleep or throw some warning and then just exit. And there are others like critical OS. So this means the platform has done it that it could do to reduce the power that your app, your system, phone is currently using, and it's not able to do it anymore. So your app probably should suspend, or like if there is a way in your application to downgrade the performance, like mostly in the games we see, right, there are high graphics and low graphics modes. So you could lower down the performance of your application by changing the graphics mode, and rather than letting go to an emergency or a shutdown state. So and there is one more called system none. So in that, system is fine. It's not having any issue running current applications that it is running on the device. Yeah, so you create this native thermal listener, and then you register the listener to get the callback by passing the context and a thermal manager that you could acquire using this API. And then whenever your app exit or you are leaving that gaming screen, and you are in some setting screens or something, and you might want to you should actually unregister and release the manager so that you don't unnecessarily leak your application. There are still more changes, and whenever release comes, there are changes in every area that happens. So we saw UI changes, we saw developer related changes. Now there are some futuristic changes like 5G. So 5G, a lot of other countries are adopted 5G already. There are states which are adopting it in a beta, like a trial phase in US, and other countries are also adopting it for a trial. So there are some APIs which are optimized for 5G experience, uh, and bandwidth estimations are also improved. So we'll go through some code. So like a normal connectivity manager, when you can register default network callback, and that in that default network callback you will get whenever the network capacity changes. So here they have introduced net capability not metered, and like you get your link estimate fast network estimations. Like if it is a 5G, then you get information of that in the network connectivity manager, so that you don't typically go like if it is not a Wi-Fi that I'll not be doing these things because it will be slower if it is not a Wi-Fi. But with 5G, the speeds are going to be very high. So if you want to make any changes in your application according to that, like if 5G is available, I can do this, and if it is less than 5G, then I will not do it. You can do that with your connectivity manager. One other thing, interesting thing is biometric authenticator strength. So now biometric APIs can give a strength of the biometric that the currently system is able to figure out. So what is biometric authenticator strength? So let's say it's a fingerprint reader or a face scan. Then you use a fingerprint reader or you are scanning your face from your device. Sometimes, not every times we do it from same angle, right? So there'll be some like confidence level attached to that API. So if you go through the biometric API, you will see that when you get the biometric manager, you can get now strength of that biometric using the biometric manager API. So what happens is, let's say you are in a finance application. So what you could do is you can have a higher strength level that okay, I'm gonna use only strong. That if it is strong biometric, then only I can use it. Otherwise, I'll ask user to enter a PIN or user to have re-authenticate herself or himself. So this will be helpful. And if there is a application which is like not that sensitive but still has a biometric authentication, then you might, depending on your use case, you might want to say that, oh, you know what, like I'm fine with even average biometric strength of like average strength of biometric rather than having an highest strength. So you can take action based on the web input the system provides. So that rather than just saying that I'm in biometric enabled, now you can have a deeper insight of yeah. So what is happening here is we are just getting a biometric manager. We are taking this. This is a constant of strong strength, and if the user can authenticate with a strength strong, then take user to enroll biometric security. So like if it is not successful, so basically you can figure out your biometric strength and take an action that if it is successful, then you can authenticate the user. If not, then you take them to settings, and you can take actions according to your use case. And next thing is yeah, basically this is available in Android X library. So and Android X library will be updated. Sorry, for with this biometric changes. Next thing is autofill and keyboard integration. So currently in Android, if there are autofill APIs available, so if there is an edit text, what happens is if an autofill is enabled by application, then it can show suggestions below that edit text. That okay, if it is an address, it can show the address which are already provided by application or a username, and phone number, all those things. But you would have noticed that your Google keyboard or a Swift key or any other third-party keyboard, they also store this information, and they can also provide that suggestions based on the fields that you are currently entering. If you start entering your name after a couple of characters, your your autos will also will show your names in the username field, and your keyboard is also showing. So it's confusing, like should I select this or should I select this, and sometimes both are not in sync. The application is not developed it, but only keyboard shows. There's a lot of ambiguity. So to solve that, instead of two separate UIs, what Android is coming up with an auto fill content inside the keyboard only, not just the drop down. So keyboards, password apps, they can get this data securely. They don't get what the data is. They can just like use that information to render it in their UI. They don't get access to what the content is itself. They just get the UI. So how would it look like is this, that if I'm trying to enter a username as password, instead of it showing some pop-up here, and like it was very tricky that you had to adapt your application also sometimes, otherwise it would overlap with other content. There were some issues in UI also. So now in your keyboard itself, you get this suggestions, and those are very easy for you to click it directly rather than going all the way to top and clicking it. And same way, if it is number, then you get your numbers here, and all this information is just provided, like all the UI is provided to the keyboard. So keyboard doesn't know about what the data actually is. Same way for address also, it can come up in your autofill. That's it from the system side, UI side, user side, everything. But there are some non-platform changes which are also under heavy developments, and one of them is your Jetpack Compose. So apart from that, there are like 70 plus libraries on Jetpack that Android team releases every 2 weeks. There's a release cycle. So some or other library will be updated every 2 weeks. And so in the new library or recent changes, if we talk about, there's a new library in the town called Hilt. It's built on top of Dagger. So integrating Dagger in a rendered application was very tricky, and it was very complex actually. So what Android team did is they sat with Dagger team, because both are internally developed in Google. So they sat with them, and they figured out what can we do, how can we make it simpler for Android, and what other use cases are there which Android related that we can handle via Dagger with some other dependency, so that it's easier for us to integrate it. So that's how they came up with Hill. You should check out the library if you're using, if you're planning to use Dagger, or if you're using Dagger already and it's happy with the setup. It's not required. Like it's not changing something drastically that you would get benefit out of it. But if you're not familiar with Dagger, then you should take a look at Hilt and then try it out. Paging 3.0. So paging library is completely rewritten in Kotlin with support of coroutines, and it's much nicer, much faster now, and supports coroutine natively, like all the APIs. Camera Access has hit beta recently. So if you're using Camera 2 API or Camera 1 API by any chance, then you should try migrating to Camera X and share the feedback with the Android team if you find any issues. And there are many, many more libraries. One of the major thing it's under development for from library Jetpack wise is Compose. So if you have not heard of Compose, it's basically a UI toolkit library from Android, written in Kotlin. It's reactive, it's declarative. So, like you don't have to go to now your XML and define something and then come to your Java or Kotlin code and then define, then get it and use it and like a recycler you kind of thing. You have to set a manager here and you can do something in XML. All those things will be taken out and it's very very intuitive to use and very less codes. It's in pre-alpha. Development is and all the developments is happening around Jetpack Compose. You can follow it. There's a Jetpack Compose Slack channel also. Like in Kotlin Slack channel, I think they have a Compose Kotlin Slack. They have a Compose channel where you can ask your questions, try it out. You will need a latest Canary build of Android Studio to check out Compose. But yeah, if you're interested in figuring like keeping an eye out of what's happening in future of Android UI development from us developers side, then you should check out Compose. Android Studio 4.0 is in stable now. It has motion editor. It has live layout inspector. So current layout inspector before Android 4.0 was you have to click every time when you change anything on your screen. You have to go and refresh it. Like you have to take another snapshot. But now it's live layout inspector that you make any changes in your application. It can detect it in real time and you can inspect those elements. 4.1 is in beta. Android Studio 4.1 is in beta 4 as of yesterday, and it has a database inspector for Room and SQLite. So this is also a very nice thing if you're using a Room database or an SQLite, that there's a database inspector which is a live, that if you make any changes in an application, you could directly see it in that database window. And if you change anything in your database, your application can also react. So if you're using Room, if you're changing a database, you get a direct callback with your live data. So that's very nice if you want to debug something, if you want to test something out, by adding something directly in database. Is your application reflecting? So you should check that out. 4.2 is in Canary, and that has this wireless debugging support. It's there added in 4.2 under Studio. Jetpack Compose, if you want to see, you should go to 4.2 Canary. Google Play Developer Console has some nice changes. So it's completely new design that they have introduced in Google Play, which was like not updated since long time. Its current Play console is like very hard to use. So now it shows you in policy status sections. So whenever Google changes any policies, that okay, now you cannot have an SMS reading capability. You need a separate waiver for that. All those things you can keep track using these policy sections, and the reports and the data like the dashboards and everything is very nice, and material time theme. Then I find current Play console like very depressing. I have to use it a lot and it's very hard. But the new one is very like a refreshed UI. There's a team management. It's in beta. So if you do release management and all, you should go to play.google.com/console and check it out. The beta version of it. It's pretty good. You will like it. So, yeah, this is pretty much everything that I wanted to cover as an overview of Android topics. But if you want in detail, there are launch videos of Android 11 which goes into each topic that we talked today, like a Jetpack Compose as a dedicated video, what's new in system UI, what's the state of Kotlin, foldables, everything as a dedicated videos. You can go to Android developer channel on YouTube, or you could go to this short link where you will see this playlist. Apart from this, there is 11 week of Android thing that Android team is running, where every week they pick up like the topic is dedicated and they'll share videos, insights, blogs, everything about the particular topic. So currently, so you see the stars on top of this week's, those are the Reddit AMAs. So Android developer tools will have a Reddit AMA, and lastly, the UI is gonna have a Reddit AMA on August 24 to 28. So if you have any questions, anything that you want to get clarified from the Android team directly, you could just go through the Android Dev Reddit subreddit, and then you can post your questions there when the AMA starts, and they'll try to answer a lot of questions out of it. You could also see what other people are posting, so that also sometimes more helpful than if you don't have any questions. And yeah, so apart from that, there is a now an Android thing that chat has runs on Medium, YouTube, podcast. So what happens is it's very hard to follow everything in Android that's happening. So every, I think, week or twice, 15 days, once he is posting it in all these formats of video, article, and podcast. So whichever is your preferable way to get the information, you should follow this now in Android. It will give you update that okay, camera X is hitting beta, and what is the new feature there, what paging library changes are coming, Jetpack Compose, everything related to Jetpack and Android. You could get it information, at least what's happening, and keep yourself updated. That's it from my side. Thank you very much for like tuning in on Sunday morning and spending 2 hours to know about what's happening in Android. This is my Twitter handle. So if you have any questions, or if you want to just connect and talk about anything in Android tech, you should just you can connect with me there. And yeah, thank you very much for having me here, Kevin.
There are a couple of questions from the comment section, so I'll just pop them on the screen now.
Sure. Can we create custom layout in conversation UI? If I'm, as far as I know, no. It's the same as your notification thing where you can add messaging style notifications. You can have a title,
Yeah,
body.
there was a similar question, just like that.
Yeah. So it's probably the same thing that we do currently with the notifications, where you pass in, where images and messaging style notification, whatever. So they're not changed much on the notification side part of it. It's just that they show in different area, and also the priority and all can be separate for a particular conversation.
And then there's one last question.
Do we need to create special activity for bubble, or we can use the notification intent screen only? So yeah, you can use your current activities. You don't have to create a new one, but you have to make it resizable. So if you go through the details of bubbles, what they suggest is that that activity which is in bubble should not have much interaction with the other part of your application. So in your let's say you have some screen where you want to pop up into a bubble, but in a normal active application of yours, you have a settings icon on top of it, which takes you to settings or take you to some other activity. So for bubble, they are suggesting that please don't do that. So otherwise, what happens is you can't have everything resizable, and you can't have your whole app ported inside bubble. So then you'll have to redirect it to a new task, and your application will open. So it will break your user's experience. So bubble should be dedicatedly just the chat and like that person related thing, that notification related thing. So if I'm chatting with you, it should just be you, me, and the chats. There should not be settings and information and picking up images from outside things. So it's mostly yeah, you should focus on the current interaction, which is immediate and focused. So there's a nice video about it also, and a detailed explanation of what is the like suggested things you should do with bubbles. Yeah.
So that's it from the comment section. So there might be more questions from the audience later on. So I hope you would spare some time in answering their doubts.
Sure, sure. You can add the comments to the recorded videos, or you can tweet to me. I'll try to answer all the questions that thrown.
So thank you for being with us today, sir, and for conducting such an informative session. So thank you, sir.
It was our pleasure to be here.
And to the audience, I would like to thank you all for watching this video. And we also have a line of events made up over the coming weeks. And if you want to stay updated with these events, you could click on the links in the description. There are 3 meetup links from 3 different organizations. You could check them out later. So I hope you guys are doing well. Keep learning, stay home, stay safe, and goodbye.
Yeah.